Hey everybody, this is Mr. Ainsworth, and we're going to get into a review on recursive sequences here, and review how to deal with arithmetic ones and geometric ones and so on. So, get your calculator out. I'm going to be using the TI-84, and let's get started here. On the first one here, we got some terms given here. We got four terms given. We have to determine if it's arithmetic. We have to find the common difference. That's the second thing. We have to write the recursive formula, that's the third thing, and then we have to find the three terms after the sequence, that's the fourth thing. So we have some work to do. So the first term is a negative 26, second term A2 is negative 16, third term is negative 6, fourth term is 4. What is the fifth term, the sixth term, and the seventh term? What are those three terms? So what we do is we find the common difference first by subtraction. The common difference is always found by taking A2 subtracting A1. So in our case, negative 16 minus negative 26. All right, that's negative 16 plus 26, or 10. So what we're going to do is we're going to add 10 to each one. So from the first term to sixth term, you add 10. From negative 16 to negative 6, you add 10. You keep on adding 10. So 4 plus 10 is 14, plus 10, 24, plus 10, 34. That's the easy part. So to rewrite it recursively, though, in terms of a sub n, what is a sub n? Equal to, notice that the second term was based upon the previous term, a sub 1, and then you add 10. The third term was equal to the second term plus 10. So I say in general that a sub n is equal to the previous term, which is a sub n minus 1, plus 10 more. That right there is what's called the recursive formula or recursive rule for the sequence. And you just need to get good at it. So once again, if you can't do it in your head, no big deal. If it's hard to figure out what you add to negative 18 to get to 2, well, okay, then find it by subtraction. Take the second term, which is 2, subtract the first term. So 2 minus negative 18, all right, well, that's 20. So you add 20 each time. So how do you figure this out? Well, simply add 20, right? So 42 plus 20, 62, plus 20 more. That's 82, plus 20 more. That's 102. Recursively, it looks like this. The second term is equal to the first term plus 20. The third term is equal to the second term plus 20. In general, I say the nth term is equal to the previous one, which is always a sub n minus 1, plus 20. Remember, this just stands for the previous term. Previous term, and that's how you get your recursive formula. All right, so let's get some more practice here. Let's try another one here. Okay, number 3. Here we go. So we got a sub 1, a1, a2, a3, a4. We got to get a few more. All right, the common difference is equal to negative 91 minus 9, which is negative 100. So you simply add 100 to get to the next term. So we add 100 here, and then add it again, add 100 here, and then add it again, add 100 here. So if you want to work this out, you enter in negative 291, and then you keep adding 100. So plus 100, boom, right there, negative 191. Negative 191. Then you add 100 again, and you just keep pressing the plus symbol, right? Add negative, or add 100, excuse me. You get negative 91. And then you add 100 again. So plus 100, and you get 9. Okay, now recursively, how do we do that? Well, A2 was found by taking A1 and adding 100. A3 was found by taking A2 right here and adding 100. We kept on adding 100, right? In general, the nth term is equal to the one before it, which is a sub n minus 1 plus 100. All that a sub n minus 1 means, it means previous. Okay? The one before a sub n is the previous one, which is a sub n minus 1. On number 4, same thing applies. What do you add to negative 17 to get to negative 10? And the answer is 7. But if you don't get that, then find your common difference. Take negative 10, subtract a negative 17. Okay, cancel out the negatives, and you get 7. So here you have to add 7. So let's do that. 4 plus 7 is 11, plus 7, 18, plus 7, 25. All right, and recursively, the second term was equal to the first term, all right, plus 7. The third term was equal to the second term, plus 7. So I say in general, any term is equal to the term before it, a sub n minus 1 plus 7. Now, it may not be arithmetic all the time. It may be geometric. So we want to determine if this is geometric. Secondly, we want to find the common ratio r. That's the second thing we do. Third thing, we want to find the recursive formula. And 4, we want to find the 3 terms. Okay, so let's do that. Okay, now to get the common ratio, we always take the second term and divide it by the first term. So r is a2. All right, so a sub 2 divided by a sub 1, and that equals negative 16 divided by 4, which is negative 4. So I'm saying that you got to take 4 times negative 4 here, times negative 4, to get to the next one. You got to multiply by negative 4. Multiply by negative 4. So what is negative 256 times negative 4? The sequence is alternating signs, so it's got to be a negative value. That's right, meaning the common ratio. So you enter in negative 256. Let me just start over here. Negative 256 times it by negative 4. Should get a positive number, 1,024. So 1,024. Now I got to multiply by negative 4 again. So times negative 4, and you get negative 4,096. Times it by negative 4 again. So what is that? So times negative 4, 16,384. Okay, so what happened there? Well, we took the second term, and that was equal to the first term times negative 4. The third term was equal to the second term times negative 4. So in general, the nth term is equal to the one before it, which is always a sub n minus 1 times negative 4, or you could write it as negative 4, okay, times a sub n minus 1. Either way, you just keep on multiplying by negative 4. You see multiplication as part of your recursive rule. Okay, number 6, you got first term, second term, third term, fourth term, and so on. Fifth term. So what do you do from here to here? Well, it kind of looks like multiplying by negative 5, right? 4 times negative 5 is negative 20, so times negative 5. The common ratio is negative 20 divided by 4, which is negative 5. So you have to keep on multiplying here. Negative 5 times negative 500 is negative 2,500. Let me just do this on the calculator here so you can see it. So negative 5 times negative 500. Negative, or positive, positive. Ugh, positive, because negative times a negative is a positive. When you multiply by a negative, you get a negative number, so it's going to be negative something, right? It's probably negative 12,500, so let's work it out. So times negative 5, get negative 12,500. Multiply by negative 5 again. So times negative 5, boom. You get 62,500. So 62,500. So recursively, it looks like this. A2 is equal to A1 times negative 5. A3 is equal to the second one times negative 5. So in general, the nth term is equal to the one before it, which is a sub n minus 1 times negative 5. Better stated would be this way, negative 5 times a sub n minus 1. You just keep on multiplying by negative 5. That's what happens in geometric sequences. All right, a couple more. Okay, first term, second term, third term, fourth term, fifth, sixth, seventh. So let me see. 1 times 3 is 3, times 3 is 9, and so on. So times 3, times 3, times 3. You just keep on multiplying by 3. So r is equal to 3 divided by 1, or 3. Fairly straightforward one here, starting with 27, because that's the last term they gave me, times 3, 81. Times 3 is 243. So 81, 243 times 3. So times 3, and we should get 729. So recursively, any term is the one before it, a sub n minus 1, times 3. Or if you want to state the 3 in front, 3 times the previous one, a sub n minus 1. Okay, on this one, what do you multiply by? Try 2, okay? Negative 3 times 2 is negative 6. Negative 6 times 2 is negative 12. Negative 12 times 2 is negative 24. So you keep on multiplying by 2. So times 2, and then times 2. So negative 48, negative 96. And then right here, if you don't know what 2 times negative 96 is, which should be what, negative 192, then work it out on your calculator. Negative 96 times 2, get negative 192. There you go. And so recursively, it looks like this. You take any term, and you multiply the one before it, which is a sub n minus 1, times this number here, 2. Or you can say a sub n is equals 2 times a sub n minus 1, 2 times the previous one. Remember, this just means previous. That's it. All right, we're rocking, we're rolling. Let's see here. Solve each equation with the quadratic formula. Negative b plus or minus the square root, b squared minus 4ac, all divided by 2a. So the very first thing you do, though, you got to set it equal to 0 first. All right, so that means subtract 7v. Also means subtract 13. So I get 4v squared minus 7v minus 13 equals 0. A is 4, b is negative 7, c is negative 13. So let's see, a equals 4, b equals negative 7, c equals negative 13. Here we go. So v is equal to negative b, or 7, plus or minus the square root of 49. Negative 7 squared is 49, minus 4 times a, 4 times c, negative 13. All divided by 2 times a, which is 4. So v is equal to 7 plus or minus the square root of 49 plus now. Why plus? I see a double negative. 36 times 13. So let's see here. Excuse me, not 36. 16 times 13. 16 times 13, 208. So 208 here, all divided by 8. Okay, sorry for the interruption there. So let's continue here. We got 7 plus the square root of 208 plus 49, that's 257. So the square root of 257, all divided by 8. That gives us two answers here, guys. All right, 7 plus the square root of 257 divided by 8, and also it gives us 7 minus the square root of 257 divided by 8. Should give us 2 decimals. So let's check out what they are. All right, so first of all, when you use a calculator, it's a good idea to use parentheses. So give the numerator a hug, put it in parentheses, all right, and work it out. So we've got the quantity of 7 plus the square root 257. Okay, bug out of the root right there by hitting the right arrow key. End it off, divided by 8. Let's see what we get. And we get about 2.879. So 2.879. Next one, what do we get? I'm going to recall my entry back, and I'm going to go up Here in the numerator, I'm going to change the plus to a minus. So minus sign now. See that? It's nice to have the calculator like that. Hit the enter button, you get the other answer, which is negative 1.129. So negative 1.129. So two solutions there. All right. Almost done. Okay, last few. Given the recursive formula, all right, that's this right here. Find the common ratio and the first 5 terms. The first 5 terms. So here we go. Common ratio is right here is negative 5. So that's r right there. R equals negative 5. And I know that because right here there's a times symbol. A sub n is the previous term, a sub n minus 1 times negative 5. So the second term is equal to the first term times negative 5. Since the first term is negative 1, what do we have? Negative 3 times negative 5, and that's 15. Let's get the rest of the terms here. So we have negative 3, and then times negative 5 is obviously 15. A sub 3 equals a2 times negative 5. So you take the previous answer, 15, multiply it by negative 5. You just keep on multiplying by negative 5. So watch this. You enter in 15 times, oops, not plus, but times negative 5. What do you get? You get negative 75. Okay, you got to take that answer and multiply by negative 5. So that's a sub 3 times negative 5. So I got to take negative 75 times negative 5. I should get positive something, right? So I multiply it by negative 5, get 375. So 375, then I got to multiply it by negative 5 again. So the fifth term is equal to a sub 4 times negative 5 equals 375 times negative 5. Notice how the multiplier is negative 5 there. Use your calculator, obviously, and make it quick. And you get negative 1875. So you keep on multiplying by negative 5. That's your common ratio. Here the common ratio r is 4. All right, so you keep multiplying by 4. So a2 is equal to a1, the term before it. Remember, this term here, this a sub n minus 1, is just the previous term. So you take the second term is equal to the previous term times 4. Well, they give you 4 as your first term. So that's 4 times 4, 16. Second term 16 because it's 4 times bigger. Third term, you got to multiply by 4. The second term by 4. That means 16 times 4, that's 64. Once again, you multiply times 4 because that's a common ratio. Fourth term equals the third term times 4. So I take my answer, 64. Okay, 64 times 4, and I get 256. So 256. Multiply it by 4. Fifth term, same thing, but multiply by 4. So I take 256 times 4, just hit the times button, times 4 equals, and you get 1024. So 256 times 4, 1024. You just keep on multiplying by 4. In terms of arithmetic sequences, you don't have a common ratio, you have what's called a common difference. Right there, the common difference equals 3. So here it says take any term is taken from the previous one plus 3. So a2 is equal to the previous one, a1 plus 3. That gives me 22 plus 3 equals 25. Why? Because when you add 3 to 22, you get 25. That's pretty simple. The third one is the second one plus 3. So I got to take my previous term 25 and add 3 to get 28. Once more, I add 3. From 22, that, to 25, I add 3. You keep on adding 3. So a4 is a3 plus 3 more, and you get 31. a5 is a4 plus 3. I got to add 3 to that. I get 34. Once again, you just keep on adding 3. Arithmetic sequences are easy. Remember, this means previous term. So the second one is equal to the previous one, which is a1 plus 8. Now, if the first one is negative 35, I take negative 35 and add 8 to it, which is negative 27. The third term is the second term plus 8. So I got to add 8 to my answer. So negative 27 plus 8 is negative 19. Fourth one, I got to take my third one and add 8. So since my third term is negative 19, I got to take negative 19 plus 8. Notice that I keep on adding 8 right there. So that's negative 11. And then my fifth term, I got to take my fourth term and add 8. So I take my previous answer in negative 11, add 8, and I get negative 3. It's so simple. You just got to understand that all you do is add 8, add 8, add 8. That's what this number represents. Okay? So that's just some more practice on arithmetic and geometric series. Do yourself a favor, do a good job, check your work, make sure the quality is good, and I'll see you on quiz day tomorrow. This is Mr. Ainsworth. See you then.